Hi guys, this is Rahul, DevOps engineer. In today's video, I will show you how Kubernetes cluster manages the pods based on the resources utilization. When we say resources utilization, it is CPU and memory utilization, right? So based on the memory and based on the CPU or memory utilization, your the our Kubernetes cluster or the master node is scale up or scale down pods, right? When there is high load on the pods, right? Then then the master node will create additional pods to overcome that load, right? And when there are less users or less load on the pods, that time the master node will ensure that it deletes the additionally created pods. So this is how our master node or the Kubernetes cluster ensure that every time they ensure the optimal use of the resources, right? Whenever it whenever need arise to have more pods, it will create more pods, and when there is no need, when there is less users or no load on the pods or the worker node, then it will delete the additionally created pods. Okay, so in this example, we will let our Kubernetes cluster to manage pods based on the CPU utilization. We are not going to demonstrate memory utilization, but we just focus on the CPU utilization. Okay, to achieve this automation of auto scaling and auto scaling down, auto scaling up and auto scaling down, we require two additional components. One is pod metric monitor, and another is horizontal pod autoscaler HPA. Okay, so how does this work? Let me explain. So pod metric server monitor the CPU utilization in the pods, right? Let's say there are four pods are running and their average utilization, it calculates the average utilization. Okay, and then that average utilization it passes to the horizontal pod auto scaler. Okay, and then based on the cutoff declared inside the HPA component, it takes decision whether new pods to be created or existing pods to be deleted. In this example, cutoff is 60%. So if average utilization of pods goes 80% or above 60%, then it will it will ask the HP will ask master node to create a new pod, right? But if the average utilization goes uh, below the threshold, below 60%, let's say it goes 20% or 40%, then it will ask master node to delete the additionally newly created pod or the additional pods. Okay, so this is how Kubernetes cluster ensures the resources utilization. Optimal use of resources, right? Okay, so two components, important components. One is pod metric server, which monitors the utilization, and then it passes that information to the HPA, horizontal pod autoscaler. Based on the decision made by the HPA, master node creates or deletes the pods. Okay, so let's go to our lab and we'll implement this there. Okay, so this is my master node. First of all, we will see what all we have in our setup. So cube ctl get pods, uh, okay, pods, okay, yeah, pod. So at this moment none of the pod is there. I mean no pod is there. Now let's see how many nodes we have. We have two nodes, one is master and one is worker. Okay, so in my diagram, if you see here, master node has the is low configuration, right? 2 CPUs and 8 GB RAM, just because it doesn't process any kind of app user data. It is just managing the nodes, okay? And my worker node having as 8 CPU and 64 GB RAM, because it is the actual production node, okay, where all your production machine or production nodes pods run, okay. Okay, so here I have two pods with one CPU and 1 GB RAM each, and the OS is CentOS. Okay, I cannot go beyond 8 pods with one CPU each, right? Because my capacity of my physical node or worker node is 8 CPU. Okay, so based on that, we can create 8 more pods. I mean, 8 total 8 pods we can create in this worker node. Okay, so that is also be taken care by the HPA. How many ports, what is the capacity of my worker node? Based on that, it creates the pod. Otherwise, I mean, it will try to create pods, but they will remain in the pending state. Okay, so now let's go to our lab, and we'll try to perform it. So as I said that we need two additional component. Okay, so one is Podmetric server. To Podmetric server doesn't come with the Kubernetes cluster. We have to get it from outside. I mean, this is a third party software. For that, I have my I have a we have to download it from this link. Okay, so I will go, I'll copy this and we'll get it here. Okay, so this is components YAML file which is downloaded. Now we just have to, because we are using we are not using any certificate, and this Podmetric server wants us to use certificates, and now we have to forcefully we have to let Kubernetes cluster know that we are not using any kind of certificates. For this, we have to update this file or modify this file. Okay, let me do it. I will show you how we can achieve this. Now we'll go to the deployment section, and here is the deployment section, right? And in this deployment section, we have to add one parameter. Okay, so the parameter is kubelet insecure hyphen tls. Okay, and just ensure the spelling one more time, and then we'll save it. Now our Podmetric server YAML file is ready. We can apply it. kubectl apply -f. So if you say matrix server created, so matrix component has been created, which will keep on monitoring the pods and will calculate the average utilization, and that utilization it will pass to the HPA, right? And based on that utilization and the cutoff setup inside the HPA will decide a new pod has to be created or the existing pod has to be deleted. Okay, now one component is ready, which is Podmetric server. Now we'll prepare our HPA. Okay, so HPA I have for HPA I have a scaler.yml file already ready. We can discuss this here. Okay, so in this YAML file, I will copy. I mean, I will provide this YAML file in the description box. You just copy there, and here we have to ensure which resource we have to specify which resource we are going to monitor. This time we are going to monitor CPU, so that is why in the resource section I mentioned the name CPU and the average utilization. Right here we have to check this. So average utilization is if this is the cutoff, right? If average utilization goes beyond 20%, then your uh, master server will create a new pod. Okay, so this is very low. In practical example it is at least 60%, but just to demonstrate here quickly, I just have uh, put it 20 because we do not have the much load on our, we can't generate much load on our pods. So manually, if we have to create, we can create, we have to do it manually, right? So just to demonstration purpose, I am putting here 20, but in practical example it, you can see here 60 and 70%, right? Okay, and now the replicas, maximum 8 pods it can create based on the utilization. Let's say if 80% utilization, then to maintain 20% it has to create 4 pods, right? So similarly, if 160% load comes, then it will get 8 pods to keep it 20%. Okay, now let's apply. Okay, so before applying this, we have to create our pods as well. Okay, so for pods, I have this CentOS deployment.yml file. Okay, let's read this file as well. What we are going to do in this file. Okay, so here we are going to create one pod. Okay, and the container which will run inside the pod will have CentOS image. Okay, and will have 1 GB memory and 1 CPU. Okay, so let's create this kubectl apply -f, and then okay, so now we can check kubectl pod has been created. Kubectl get pods, one pod has been created. Let's see how many resources, let's see whatever we have specified it, whether the pod has been created accordingly or not. So to check this detailed information about pod, we have to run command kubectl describe and the object type and then the object name. Okay, so here if you scroll it up, we will see here limits. Okay, so this is how this is what we specify in the YAML file, and this is what we received in our actual pod. Okay, so it is based on, it is accordingly our YAML file, so we are good. And now this is the IP of my pod. Okay, so we can IP of my pod. Okay, and its status is running. Okay, so we can run this command also, kubectl get pods -o wide. So here this is the name of my pod, status running, age just 84 seconds ago it was created, its IP address, and at the node where it has been created. Okay, now we have deployed Podmetric server, we have created pod, and now we have to uh, set up HorizontalPodAutoscaler component. For that, I have already, as I show you, I have already prepared this file. Here we have mentioned average utilization 20%, cutoff 20%. So let's apply this file, kubectl apply -f scaler.yml. Okay, so it says HorizontalPodAutoscaler.scaling.autoscaling/HPA created. This is the name of our HPA component. Okay, so let's see everything in one place now. Kubectl get all. Okay, here you see the pod name and the horizontal pod scaler. Okay, so here it says that the target is CPU 20% is my cutoff. Minimum pod it will always have at least one pod. Max it can go 8 pods based on the utilization. Okay, so now we will increase load on our pod or the container which is running inside this pod, and then we will see how the Kubernetes cluster will automatically manage these pods creation and pod deletion. Okay, now let me go to the other side, and I have to start the live view of my Kubernetes cluster. So this is the command watch kubectl get all to see the live view of your Kubernetes cluster. Okay, I just hit the enter, and now this is my live view. And now I will go here, and here I will log into my Kubernetes pod. This so kubectl exec, and the command is -it -bash. Okay, this is the command. So command is kubectl exec, and then the pod name. Okay, and then -it -bash. Okay, so here let me run some crazy command. While true, do du -sk asterisk slash asterisk slash asterisk slash asterisk. So nesting, it might create some load on CPU. Nesting utilization, and then I have just started this command. Let me go to the live view now. So here, so if you see, you just have to monitor this section CPU 1. Okay, and we will see now utilization is 74% average utilization. So based on that, it decide the Kubernetes cluster on master node is created 3 additional pods. Okay, and now it is now again is going 98%, so it has created 4 more pods. Okay, so now it will wait whether the utilization stabilize or not. Now it is just 24%, so it will. Okay, so the total utilization of from the all 5 pods, I mean this average utilization from the pods. Okay, now it came down to 19%, so now it will stop creation of additional pods, right? So now it will maintain this state. Okay, because it is 20 below the cutoff, right? Now if I go and if I stop this command, the utilization will start coming down, right? And then what it will do, based on that utilization, it will monitor that utilization for 5 minutes, which is cooling period, right? And if it still remains below 15%, then it will decide to terminate few pods based on that utilization. Okay, so let's wait what number comes here, right? So now because we have stopped the command that generated the load on the pod, so it's showing 0%, and now based on that 0%, it will try to maintain one pod only, because earlier when there was one pod, the utilization was 0. So now it will try to terminate the newly created pods. Okay, when I say newly created, so it decides which pod has to be deleted based on the age. So the most recently created pods will be terminated. So the cooling period is 5 minutes, so it will wait for 5 minutes, and then after 5 minutes of uh, cooling period, then it will start terminating those newly created pods. So this is how your Kubernetes cluster works, right? And this is very important part of DevOps, that and this is the ultimate objective of the Kubernetes cluster, right? To manage pods when based on the utilization of resources, and this generally used by the commercial applications, right, where more in the peak hours, let's say more users are accessing the website, right? So that time in the backend there should be more servers or more pods, more containers to process those requests, right? But in non-peak hours when there are less users, then additional pods are not required. So that time Kubernetes cluster will delete those pods. So it it like it shows how Kubernetes cluster uh, use resources it's optimum use of resources, right? Optimal use of resources. This is the ultimate objective of the Kubernetes cluster, right? So let's wait when it will start terminating the pods. So again I'm saying that the most recently created pods will start terminating first, right? Based on the utilization. And then you will see the number change in number here as well, right? Let's wait a couple of more minutes when it will start terminating these bots. Okay, so very important feature of Kubernetes cluster, right? Okay, so now is 5 minutes 18 seconds. Maybe when it will reach to 6 minutes it will start terminating, because it calculates the time when the CPU utilization started coming down, then down the 20%. Okay, so since then the time will start, not from the its initial age. Okay, so let's say when the age was 1 minute or 2 minute, then the load average utilization started coming down. So since then it will calculate the 5 minute. Okay, okay, so now it started terminating this pod. Okay, okay. Okay, so this was the pod which was the pod which was most recently created, and now it started terminating the additional newly created three more pods. Okay, so four pods are being terminated here now. Okay, so this is how automation or this is how the uh, automation of auto scaling and auto scaling up and auto scaling down works in Kubernetes cluster, and this is how Kubernetes cluster manages your pods based on the resource utilization. Okay, so let's back to our terminal and exit from the pod. Okay, one more thing I want to show you here, the resource allocation inside the pod. Okay, okay, so this command we will execute now to, okay, so see whether our pod has been created according to our the components which we specify in the YAML file or not. We can see this here: cube, ctl, describe, and then the object and the object type. So object type and then the object. Okay, so if you run this command here, you will see your resource allocation of your pod here, right? So it is based on our YAML file. Yeah. So let me cancel this. So I hope uh, you will perform this in your own setup and will try to understand how your automation works in the Kubernetes cluster.